Yes, Sashikal students. Well, today we will discuss what is Euclid Division lemma. Euclid was the name of a mathematician. It's used for division and to find HCF. Lemma is, you can say, it's a kind of helping theorem. It's a kind of helping theorem, a theorem which helps to prove other theorem. It's a statement which helps to prove something else. We can also say this is auxiliary theorem. So what is Euclid division lemma? If we have any two positive integers a and b, there exist unique integers q and r satisfying a is equal to bq plus r, where r is less than b, is greater than 0 or equal to 0. Now students, first let's split this into two parts. First part is a is equal to bq plus r, and second part is this one. Let's understand them. So what is a is equal to bq plus r? We already know this students. Only thing is we don't know it is Euclid division lemma. Since fourth standard we have been doing this. Now we want to take two integers a and b. Let's say I take a is equal to 52. Preferably I take a greater than b and b is equal to 5. Now let's see, I want to divide both. So how will I divide? I'll put 52 inside and I will divide by b, that is 5. So I will get 5 tens are 50. Now 2 minus 0, 2 is the remainder. Now students, see, I may give this 2 name as r, which is the remainder. 10 is the quotient. I can give it q, this q. 52 is the dividend. I want to divide 52. I will name it A, the biggest of all. And the divisor 5 I will name as B. So what does it become? Right from 4th or 5th standard, we know that 52 would be equal to, that is A, would be equal to B divisor multiplied by quotient. So I can say divisor is 5 multiplied by 10 plus r, that is remainder. In this case it is 2. So I get 5 into 10, 50 plus 2, that is 52 is equal to 52. Correct. It is proven. So once I have understood this, now let us see what is the meaning of 0 less than or equal to r less than b. Students, it can be divided further into two ways. One is 0 is equal to r but less than b, and second is 0, sorry, r is greater than 0 but r is less than b. Now we know students what is b. B is the divisor. For any two integers, preferably for simplicity we can say a is greater than b. Otherwise, we can't divide. 52 is to be divided by 5. 5 is kept outside, 52 inside. So, let's take these two cases. See, in this case only students, you see that 5 is not the factor of 52. Means you can say B is not the factor of A. When B is not the factor of A students, then this condition would apply. R would be greater than 0 but less than B. The value of R, that is remainder, will range between 0 and B. It will be, I'll give it open interval. It will be less than B. It will be greater than 0. When B is not a factor of A, there will be remainder. It will be greater than 0. Like in this case. In this case, you can say 52 is having factors like 52, 1, 2, other factors, but 5 is not factor of 52. So what is remainder? R is equal to 2 in this case, right? So R2 is greater than 0, but it is less than divisor. Now what is divisor? R is 2, remainder is less than, what is divisor? Divisor is 5. Always students, R will be less than divisor but greater than 0. In which case? In case your B is not a factor of A. Okay. The second case, students, when B is a factor of A. So we can take a simple thing. We can divide 50 by 5. So I will put A inside, that is 50. I will put B outside, divisor 5. I will simply get 5 tens are 50. Now in this case, what is remainder? R is 0. So I can write this division in the form of Euclid division lemma, how A, that is dividend 50, is equal to divisor. Always write divisor first, divided by quotient. Quotient in this case is 10. You see, students, R is 0. R is 0 because in this case our B was a factor of A. 5 is a factor of 50. So this will be applicable for all the positive integers A and B. We have done this. Student, division algorithm, division, Euclid division lemma is there. And then we have another name normally given to this, Euclid division algorithm. When I talk about algorithm, we have calculators. Everyone has seen scientific calculators and normal calculators. These calculators are designed, they do calculations based upon the algorithms. So basically, you know, it's a fixed step-by-step procedure, that is algorithm. Having defined Euclid division lemma, there is a corresponding algorithm to this, which will find the HCF of any two numbers. So let's see how we can use Euclid division lemma either to divide or to find the HCF of two numbers. All right. So now students, we know what is Euclid division lemma. A is equal to BQ plus R. It's very important to write this, that R ranges between 0 and B. R is less than B, R is greater than 0, and when A is a factor of, B is a factor of A, in that case R is equal to 0. Very good. Now students, we can take two numbers, A 93, B I can take as 12. So this is one case, and other one I can take as A as 252. I can take B as 180. So see now how Euclid division lemma is helping us to find out the HCF. We want to find HCF of 252 and 180. One is prime factorization. You can do prime factorization of this number. You can do prime factorization of this number, and whatever are the common factors, highest common factor you can take, that will give you HCF. But now we want to do the HCF by this method, right? So what I do, you see, here I write 252 inside because 252 is greater, and B 180 is the divisor outside. This is my A, right? So now I divided 180 ones are 180. I will subtract this just like I do in the normal division. I get 2 here, I get 7 here, 72. Okay. Now, how I express this step, how I express this step, so I can write it here. I will do this example later. There's a small confusion in this. That's why I shifted to this example. I'll tell you what. So here, how will I write? In this form, I can write 252. This is my A is equal to B, BQ. B is 180 into what is Q in this case? Q is 1 plus what is the remainder? 70. Very good. This is my first step. Students, I want to continue doing these steps till I get this remainder is equal to 0. When I get remainder is equal to 0, in that step, whatever is my B, means divisor, that will be the HCF of these two numbers. So now, in order to understand the second step, what I do, I I keep having 72 here, and I put this divisor, I make this divisor as dividend in this case. So 180 goes inside, right? Now 72, 1 is 72, I can still go further, 72, 2 is 144, right? I subtract this, I will get 10 minus 4, 6, 9 minus 4, 5. So I'm sorry, I get 156, I get 36 here, right? 144 plus 36 is 180. All right. Now my remainder is not 0, but how do I express this step in terms of the Euclid division lemma? So it would be, now what is my dividend? 180. I will write 180 here, right? Would be equal to divisor. My divisor B in this case is 72. Very good. I have multiplied 72 by Q. 2. This is my Q. 2. And what was the remainder? Remainder was 36. So students, this is my second step. It's over. My HCF is little bit more far away maybe because R is not equal to 0. I have to keep continuing till my R becomes 0. Now again, next step, what I do, I imagine 36 remainder to be divisor, and this 72 initially was divisor. In the second step, in the third step, it becomes dividend. So 72 comes inside. Now you can guess, students, 36, 2 is a 72. Now nothing here. 72 minus 72 is 0, means my remainder is 0. If my remainder is 0, then students, something very interesting. What is my HCF? In the last step, when my remainder became equal to 0, my divisor is the HCF of both the numbers. So I will write anyway. I will write the third step. What? 72 was the dividend. I'll write 72 here. See that? 180 getting shifted here. 72 getting shifted here is equal to, I'll write BQ. My focus will always be here. B is my divisor. In this case, my divisor is 36. I have multiplied 32 by 2. I got 72 only. So my remainder was 0. Wow. When my remainder is 0, my job is done. Then what is the HCF? I have already seen. In the last step, the divisor is my HCF of given two numbers. In this case, it was 252 and 180. So I can write HCF of 252 and 180 is 36. I can always confirm it also, 252, 180. See students, 252 and 180. If you factorize, 252 is, we can divide by maybe 4. So 4 6 are 24, 4 3 are this, and then by 3, 3 2 are 6, 3 1 are 6, and then 7 3 are 21, right? And 180, so we can take here maybe 6, 6 3 are 18, 0, and 6 5 are 30. So students, 252 prime factorization will be, for 4 it is 2 into 2 into 3 into 7 into 3. For 180 it is 6. I'll convert this into prime factorization, 3 into 2, again 3 into 2 into 5. Now what are the common factors? See students, 2 2 is common. This 2 2 is also common. Then this 3 3 is also common. That's all. So by prime factorization, what is the HCF? Take all the common factors, multiply them, 2 into, then 2 into 3. So this is 3 2s are 6, 6 2s are 12. All right. But I've done a mistake. This 3 is also common, right? So still you multiplied by 3. So 12 3s are 36. So this is how students, Euclid division lemma is helping us to find the HCF of two numbers. Suppose three numbers are given. Then first you find HCF of two numbers, then take that number and the third number. In the same way, you can find HCF of n numbers. If you like this video, students, don't forget to subscribe our channel, Learn CBSE. So 10 years of engineering and 8 years of university level education, we combine together to give you the best videos. Do subscribe and share with your friends. Thank you very much.